Hi everyone, and welcome to a review of how to solve the infamous mixture problems. These problems are a favorite type of question for SATs and other types of tests like that. So let's talk about the strategy we use to solve them, and then I'll go through some examples. So the strategy is, of course, to identify the variable. That is the first step in almost every word problem you will ever see. Then we're going to try and write equations from the given information. Now, sometimes you're just going to need one equation, and sometimes you need two, depending upon how much information they've given you and how many variables they have in the word problem. So one equation is going to be built using the percentages, which you will rewrite as decimals. And remember, it's the percentage times the amount is going to equal what you get. And the second equation is generally going to be built using the total amounts. So if you need a second equation, that's generally what you're going to be using. And then you're going to solve either just the plain equation or solve the system of equations. Most of the mixture problems I see tend to have two variables, but we're going to start off with an example that has only one variable. A manufacturer of soft drinks advertises their orange soda as naturally flavored, although it contains only 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to conform to this new regulation? So the clue as to what our variable is right here. It says how much pure orange juice. So our variable is the amount of pure orange juice. Once I've identified the variable, I'm going to organize my other information and try to create expressions and equations from that. So we're going to start off by looking at what it originally had. So originally we had 900 gallons of drink at 5% juice. And we know that for the juice that we're adding to it, we have X gallons, because that's what we want to find out, at 100% juice. So if I change my percentage here to a decimal and multiply by the 900 and add it to this percentage as a decimal times X, I need to get 10% of my new amount, which is X plus 900, to be juice. So let me show you how that looks in an equation. In my equation, I wrote 5% times 900 plus 100% times X equals 10% of my new amount, and it's 900 plus X because I don't know how much I'm adding. Now all I need to do is solve this equation. I start by multiplying. 0.05 times 900 is 45. 1 times X is X. And I distributed the 0.1 into this parentheses here. I got 90 plus 0.1X. Now I get my x's to the same side. I subtract the 0.1x to this side, and I subtract the 45 to the other side. And then I divide, and I find out that X is 50 gallons. So they need 50 gallons of pure orange juice to add in to meet this federal requirement. Let's take a look at another example now where we have to make two equations. It says you need a 15% acid solution for a certain test. The supplier only ships a 10% solution and a 30% solution. How much of each solution should you mix together to produce 10 liters of a 15% solution? Now notice we have two variables here because it says how much of each. So I need to know how much of the 10% solution I need and how much of the 30%. And because there are two variables, that's the big clue that we need two equations. So let's start off by writing out what we know. So we're going to identify the variables, and we're going to write out the other information that we're given. So I need X, the liters of the 10% solution, and Y is the liters of the 30% solution. So if I wanted to write an equation with this information, I would change my percentage to a decimal, multiply it by X, and then change this percentage to a decimal and multiply it by Y. And that's going to equal, if I add it together, it will equal 15% of 10, so 0.15 times 10. So let me show you that equation. I have 0.1 times x plus 0.3y equals 0.15 times 10. Now you can, of course, multiply this and get 1.5. That's up to you. I just left it there so you could see how I did it. It's 10 liters, and I need 15% of that to be acid. Now, the other equation is going to be the total amounts. So let me show you how that's built. I have the amount of the 10% solution plus the amount of the 30% solution equals the total number of liters I need in the end. So these are my two equations. Now you can choose any method for solving your system of equations. I prefer solving by elimination, so that's how I'm going to do it. And what I'll do is I'll multiply this bottom equation by negative 0.1, and that will cause my x's to cancel out. So I multiplied by negative 0.1, and I lined up my systems, and now I'm just going to add. I have 0.1x plus negative 0.1x will cancel out. 0.3y minus 0.1y is 0.2y. And 1.5 plus negative 1 is 0.5. Now all I have to do is get y alone by dividing. 0.5 divided by 0.2 is 2.5. So y is 2.5 liters. Now for x, all I need to do is say if x plus y equals 10 and y is 2.5, I can just subtract 10 minus 2.5 to get 7.5 liters. So my final answer is 2.5 liters of the 30% solution and 7.5 liters of the 10% solution. Now, be careful when you're writing your answer, because a lot of times I forget to write down what x and y represent, and then I forget and I accidentally switch the amounts of each thing. So always write down what they represent so you know that x is the 10% solution, so this is 7.5 of the 10%. You know y is the 30%, so this is 2.5 of the 30%. Make sure you've written that down so you don't get confused later. So that's it about the mixture problems. Let me know if you have any questions.